area of circle, we already learned what is the formula for area of circle in our lower classes. Area of the circle is pi r square. How we are getting the area of the circle formula? Area of the circle is equal to half into circumference of the circle into radius. So circumference of the circle 2 pi r into radius is r. If you are just simplify this, so 2 get cancelled. Okay, pi r into r is pi r square. Area of the circle is equal to pi r square. Next, area of quarter circle. Okay, quarter circle means only this portion. Okay, so circle is divided in 4 quarters, equal area. So this is one of the quarter. If you are just taking this one of the quarter, okay, each quarter angle it will form 90 degree. Okay, this is 90 degree, or we can say 1/4 of pi r square. Area of the quarter circle is 1/4 into pi r square. Okay, area of semicircle is equal to half into pi r square or pi r square by 2. Area of the sector. Okay, area of the sector of the circle. Okay, area of the sector. So this area we have to find out. For finding this area of the sector, the formula is, okay, pi r square into theta by 360. Okay, so pi r square into theta by 360. So area of the sector we can just write it as theta by 360 into pi r square. Okay, in 10th standard, the same formula we are learning in 10th standard, we are learning in theta by 360 into pi r square. Okay, mostly we'll go with this theta by 360 into pi r square. This will be easy to use. If you are writing pi r square into theta by 360 also, we are going to the same answer. But theta by 360 into pi r square also is going to be the same answer. Okay, so mainly we must know area of the circle pi r square, and we'll be using area of the sector theta by 360 into pi r square. Okay, so keep these formulas in your mind. Okay, now let's start with exercise set 6.3. Okay, exercise set 6.3, first question. So they are given, unless state otherwise, use the approximation 22/7 for pi value. If they didn't mention anything for pi value, how to consider 22/7. If they stated 3.14 means you have to use 3.14. Now first question. So find the area of the sector of a circle which radius is 7 centimeter if the angle of the sector is 60 degree. Okay, so radius is given. So radius is 7 centimeter and the angle of the sector. Okay, the angle of the sector is given 60 degree. Okay, for our wish, okay, for our understanding, we can just draw the diagram, take the triangle. Okay, circle, radius 7 centimeter, angle is given as 60 degree. They are asking area of the sector. Okay, so we know the area of the sector formula. First, you just write what is given. Okay, so given radius is equal to 7 centimeter. Next, angle theta. Okay, angle theta is equal to 60 degree. They're asking area of the sector. So area of the sector. So area of the sector, either you can use pi r square into theta by 360, or we can use theta by 360 into pi r square. Okay, theta by 360 into pi r square. So theta value is given that 60 degree, 60 by 360 into pi value 22/7 into radius is 7. Okay, 7 into 7. 7 square, so 7 into 7. Cancel 7, 7 get cancelled. 0, 0 get cancelled. 1, 6 are 6. 6, 6 are 36. Again, 2 table. 3 2s are 6. Here 11 2s are. Okay, further we just left out with 11 into 7 by 3. So 11 7s are 77. Okay, 77 divided by 3. Okay, 77 dividing by 3. So if we are dividing 77 by 3, so we'll be getting 2 3s are 6. Balance 1. Okay, it will become 17. 5 3s are 15. So balance 2. Okay, it will become 20. Next, so 6 3s are 18. Okay, 6 3s are 18. Again 6 3s are 18. So it will be go on like this. Okay, therefore the area of the sector is equal to 25.666, okay, centimeter square. So we can just write therefore. So area of the sector is equal to 25.6666 centimeter square. Okay, area unit is, okay, square unit. So you have to take it as square unit. Okay, so we're just applying the formula, substitute the value, and then simplify it. So question number 2. So find the area of the quadrant. Find the area of the quadrant of a circle whose circumference is 44 centimeter. So quadrant means it's forming 90 degree. So quarter of the circle whose circumference is given. Okay, circumference is given 44 centimeter. Okay, so let me show the diagram. So this is a circle with a quarter circle. It's forming 90 degree and radius is not given. So we have to find out the radius. Instead of radius, they have given, okay, circumference. They have given the circumference. Okay, if it's a quarter circle means you can go with this. Okay, 90 degree. Okay, so as they are given circumference, right? So first the solution. So what is given first? Circumference is given. A circumference is equal to 44 centimeter. So we know that circumference of the circle is 2 pi r. Okay, so 2 pi r is equal to 44 centimeter. Now 2 into, so pi value 22/7 into r is equal to 44. Now keep only the radius, okay, r value this side and bring balance to the next side. So it will become 2 into 22, okay, 44, or one more step will write. So 2 into 22 is 44, okay, 44/7 into r is equal to 44. Now take this 44/7 to this side. So 44/44 into 44/7, it will become 7/44 while we are taking to the next side. Now 44 get cancelled. So now radius is equal to 7 centimeter. Now radius is 7 centimeter. Angle is given as 90 degree. So they are asking area of the quadrant. Okay, area of the quadrant. Therefore, either you can go with the direct formula. Okay, what is the direct formula? 1/4. Okay, pi r square, or theta by 360 into pi r square. Instead of theta, we can just take it as 90 degree. Okay, otherwise we can go with area of the quadrant. Quadrant 1/4 pi r square. So direct formula also you can use. In case if you doesn't know, you can write the formula theta by 360 into pi r square. Okay, so area of the quadrant of the circle is 1/4 into pi r square. Okay, pi r square. So 1/4 into pi value 22/7 into radius is 7. Okay, 7 into 7. You can cancel 7 sevens are get cancelled. Okay, 2 2s are 4. Here 11 2s are. So balance, okay, is 11 into 7. So divided by 2. Okay, 77 divided by 2. Okay, 77 divided by 2. So 38.5 centimeter square. Okay, centimeter square. So area of the quadrant of the circle is 38.5 centimeter square. So question number 3. The length of the minute hand of a clock is 7 centimeter. So find the area swept by the minute hand in 10 minutes. Okay, 10 minutes. So we can go with the rough sketch first. So now this is the diagram. Okay, circle. Okay, clock is in the form of circle. Okay, so here's given. The minute hand is 7 centimeter. Okay, so the minute hand is 7 centimeter. That is nothing but radius is 7 centimeter. So we can just take the radius is 7 centimeter. And they are asking the area swept by the minute hand in 10 minutes. Okay, 10 minutes means so from here to here. From here to here. So 10 minutes. Okay, one thing you have to make a note in a clock. Okay, every 5 minutes it's forming 30 degree. Okay, every 5 minutes it will form 30 degree. So here 10 minutes. So 30 plus 30 for 10 minutes will be having 60 degree. Okay, for 10 minutes will be having 60 degree. For every 5 minutes, okay, the angle will form 30 degree. So 12 numbers, okay, 12 into 3, okay, 12 into 30. So 12 30 so 360, okay, full angle we will get. Okay, so each angle will be, okay, each 5 minutes will be having 30 degree, okay, 30 degree. Keep it in your mind. Okay, so here in 10 minutes we have 2 5 minutes, correct sir? So 30 plus 30 will be having 60 degree. Okay, now the theta is equal to 60 degree. The radius is equal to 7 centimeter. Okay, so from this I can just take what I can do. So radius is equal to 7 centimeter, and theta is equal to 60 degree. So the area of the sector, now this is in the form of area of the sector, theta by 360 into pi r square. Okay, so theta by 360 into pi r square. Okay, area swept by the minute hand is equal to area of the sector. Area of the sector formula, theta by 360 into pi r square. 60 by 360 into pi value into, okay, pi value into, okay, pi r square. Okay, 7 square. 7 square means 7 into 7. Okay, now we can just simplify it. Okay, 7 7 get cancelled. Here 3 2s are 6, and here 11 2s are, so 1 into 11 into 7 into 1. Okay, so 77 by 3. 77 by 3 is 25.6666 centimeters square. Okay, so area solved by the minute hand in 10 minutes is equal to 25.666 centimeters square. Now question number 4. A chord of a circle of radius 10 centimeters subtend 90 degree at the center. So find the area of the corresponding minor sector and major sector. Minor sector and major sector. So two cases we have to find out. First we will find out minor sector. Second we will find out major sector. So the radius is given as 10 centimeter. Angle is given. Theta is given as 90 degree. Okay. So let me go with the diagram. Okay. Now this is the diagram. Okay. So radius 10 centimeter, and so angle is given 90 degree. Okay. Now here we have two sectors. One is this white portion is minor sector. Okay. Now this portion is major sector. Okay. Minor sector, balance is major sector. So for both they are asking the area. Okay. So finding minor sector area is like quarter circle. Okay. We can go with quarter circle formula, that is 1 by 4 pi r square. Or we can go with theta by 360 into pi r square. So we'll be getting this. Okay. For finding major sector, so angle it will be theta is equal to 270 degree. So how we are getting 270? So total is, okay, we know that full angle, okay, full angle is 360 degree. So 360 minus 90. So we'll be getting 270. Okay. So this area, this portion is, the degree is 270. So theta by 360 into pi r square. This is one way for finding the major sector. So one more way also is there, right? If you are not going with, so again the sector formula. So what you can do, area of the full circle minus, okay, area of the minor segment. So minor sector, area of the circle minus area of the minor sector, you will be getting so major sector. In both the ways you can just try it. Okay, so let me show the answer. So first one, okay, first you write what is given. So given radius is equal to 10 centimeter. So next, okay, for the minor sector theta, okay, minor sector theta is given as, so 90 degree. Okay, so now we can find out area of minor sector. Okay, area of the sector, so they have given the name, area of the sector OABB, right? So if you are writing this is OA, so we can just take one point here, that is PB. So otherwise you can write area of minor sector, okay, area of minor sector. So the formula is theta by 360 into pi r square. So here we have given us theta by 360 into pi r square. or we can go with area of quarter circle. Quarter circle also we can use. That is 1 by 4 pi r square. Anyway, if you are simplifying this, you will be getting 1 by 4 only. Correct? So 0, 0 get cancelled. 1 nines are 9, 4 nines are 1 by 4 only will get. And here instead of pi value, you have to use 3.14. Okay, pi is equal to 3.14 approximate value. And radius is given as 10. Okay, 10 square. 10 square is 100. So 3.14 into 100 is 314. So divided by 4. So we are just dividing by 4. First you can just simplify with 2 table. 2 twos are here. 15 twos are 30, balance 1. Okay, 7 twos are 40. So we are getting as 157 by 2. 157 by 2. So the answer is 78.5 centimeters square. Okay, 78.5 centimeters square. Now that is area of the minor sector. Area of minor sector. So next we have to find out area of major sector. So major sector we have two ways. So area of the major sector. Okay, area of the major sector is area of the circle minus area of the minor sector. Okay, OABB. If you are subtracting this, you will be getting the balance. That is nothing but area of major sector. Okay, otherwise you can go with area of the sector formula. We have to take the angle is theta equal to 270. Okay, so that also will be getting the same answer. Okay, so both I will just explain. Now area of the major sector is equal to area of the circle. Area of the circle formula pi r square. Theta, sorry, pi r square. Pi value 3.14 into 10 square. So 314 centimeter square. Area of full area, right? Area of the circle is 314 centimeter square. Now we have to find out only the major sector. Okay, the shaded portion. Shaded portion means area of the circle minus area of the minus sector. So just minus it, 78.5. So 314 minus 78.5 is 235.5 centimeter square. Okay, centimeter square. Okay, this is one of the way. So in case, if you want to go with another way, okay, so area we can write it as area of major sector is equal to theta by 360 into pi r square. So theta you have to consider as 270. Okay, 270 divided by 360 into pi value 3.14 into r square. Okay, radius 10 square. So simplify this. Okay, simplify this. You will be getting the same answer as 235.5 centimeters square. So both are in the same. Right. So now question number 5. Question number 5. So here a chord of a circle radius 15 centimeters subtended an angle 60 degree at the center of the circle. So find the area of corresponding minor and major segment. Okay, major segment, not sector. Okay, so they are asking corresponding minor segment and okay, major segment. Okay, segment means now, so segments we already given the definition for segment, right? A segment means the region between arc and the chord. Okay, this is segment. Okay, the shaded portion is the segment. So region between arc and the chord. So how to find out area of the segment? So area of the segment means area of the sector. Okay, area of the sector minus area of the triangle. Okay, this is the formula. Area of the sector. Okay, area of the sector means this is the area of the sector, right? So this is area of the sector. So minus area of the triangle will be getting area of the segment. Minus segment. For finding the major segment, so area of the circle minus area of minor segment. So you'll be getting so major segment. That is the concept, right? Area of the segment, okay, ABB is equal to area of the sector minus area of the triangle. Okay, so area of the sector we know how to find out the form, how to find out theta by 360 into pi r square. Just let's apply the value. So area of the sector theta by 360 into pi r square. Theta value is 60. 60 by 360 into pi value. They asked us to use 3.14 into 15 into 15. So cancel it out. Okay. 0, 0 get cancelled. 1 6 are 6, 6 6 are 36. 1 by 6 into 3.14, 15 into 50. Again, so cancel with 3 table. Okay. So 2 3s are 6 here. 5 3s are 50. So 1 by 2 into 3.14 into 5 into 50. So just multiply everything. Okay, 117.75 centimeters square. Okay, area of the sector is 117.75 centimeters square. Next, we have to find out area of the triangle. Okay, so in this chapter, area of the triangle means, okay, always you can go with root 3 by 4 a square. Okay, mostly it will come as equilateral triangle. Okay, equilateral triangle. Now, this is 60-degree means, how can I say this is an equilateral triangle? This is 60-degree, this is 15, 15. Actually, two sides are equal means isosceles triangle. If it's an isosceles triangle, base angle should be equal. Okay, base angle should be equal. Therefore, this should be 60-degree, this should be 60-degree. Therefore, if you are adding all the three angles, you will be getting 180-degree. Angle sum property will satisfy. If all the angles are 60-degree, we can say this is an equilateral triangle. So, area of an equilateral triangle is root 3 by 4 a square. Okay, area of the equilateral triangle is root 3 by 4 a square. Now, area of the equilateral triangle is root 3 by 4 a square or side square. The side is nothing but 50. Now, instead of root 3, we have to take the value for root 3 is 1.73. We have to substitute 1.73 by 4 into 15 square. 15 square is 225. 225, same step only is repeated. Okay, just multiply and divide with 4. We are getting as 97.31. Okay, you can just take up to 2 decimal or 4 decimal. 3125. Okay, maximum you can just go with 4 or 2 decimal part is still enough. Okay, 97.31. Now we have to find out area of the segment. So area of the segment means area of the sector minus area of the triangle. Okay, let me subtract, so we'll be getting the answer. Now area of the segment. Okay, area of the segment is equal to area of the sector minus area of the triangle. Area of the sector we found out 117.75 minus area of the triangle is 97.3125. Just subtract, will be getting us 20.4375. That is the answer. Area of the segment. So this segment portion. So next again they are asking area of the major segment. So major segment means except this. So all the whited portion. How do you find out area of the circle minus area of the minor segment? Okay, area of the circle formula pi r square minus 20.4375. So pi value 3.14 into 15 square, that is 225. So multiply it and subtract, you'll be getting 686.0625 centimeters square. Now that is the area of major segment. Major segment means except this, except blue color, everything is major segment. Question number 6. A car has two wipers which do not overlap. So each wiper has a blade of length 28 centimeter and weaves through an angle of 120 degree. So find the total area clean at each sweep of the blades. So we have two blades. Okay, it's cleaning the area we have to find out for two blades. The wiping area of the blade will be in the form of sector. So two blades we are using it. So 2 times we have to take the sector. So we know that area of the sector formula. Okay, theta by 360 into pi r square. So radius is given as 28. Now this is, we can just take it as it's a radius, and angle is given as 120 degree. 120 degree. So apply the formula for area of the sector. Area of the sector is theta by 360 into pi r square. Okay, just apply the formula. Right? So total area cleaned by the two wipers is equal to 2 times the area cleaned by one wiper. So one wiper is in the form of a sector. Okay, 2 times area of the sector with angle 120 degree. So 2 into area of the sector formula theta by 360 into pi r square. So theta value is 120, 120 by 360 into pi value 22 by 7 into radius is 28, the whole square. Okay, expand. We can cancel 0, 0, 0, 0 get cancelled. 1 12s are 12. So 3 12s are 36. So 28 into 28. So again, we can just simplify. Okay, 1 7s are 7. Okay, 4 7s. So just multiply all the numerator. We are getting as 4,928. So divided by 3. So the final answer is 1642.666 centimeter square. Okay, the total area cleaned by the two wipers is equal to 1642.666 centimeters square. Now, question number 7. A chord of circle of radius r subtended angle of 60 degree at the center of the circle. Show that the area of corresponding minor segment of the circle is equal to pi r square 1 by 6 minus root 3 by 4. Okay, actually some mistake is in the question. This should not be pi r square. Okay, actually this should be like in the form of, okay, so pi will not come inside, outside. So pi will not come outside. This should be pi by 6. That is only correct statement. Pi by 6 minus root 3 by 4, we have to prove it. Okay, how we can proceed? First, we'll go with the diagram. Okay, now this is the diagram. Okay, a circle with radius r and making an angle subtended is 60 degrees given at the center. So they are asking to find the area of the corresponding minor segment. Okay, the blue area. This is the minor segment. So we know that area of the segment. Area of the segment is equal to area of the sector minus area of the triangle. If the triangle is 60 degree, we can say, right, this is an isosceles triangle. If it's an isosceles triangle, again, we can say that base angles, it will be equal. So everything, it will become 60 degree. So we can say this is an equilateral triangle. So triangle, it will be equilateral triangle. So area of the segment is equal to area of the sector minus area of the triangle. Area of the triangle. So we can just apply it. So first you'll find out area of the sector. Okay, so now this is equal to, so area of the sector formula theta by 360 into, okay, theta by 360 into pi r square. So minus area of the triangle is, okay, that is equilateral triangle formula is root 3 by 4. Okay, side square. Side is nothing but r. Okay, root 3 by 4 r square. So now we can just substitute the value. Okay, theta value is 60. 60 by 360 into pi value. Okay, pi we will keep as it is. Okay, we no need to substitute the value for pi. Okay, pi into r square minus, okay, root 3 by 4 r square. Simplify it. 0, 0 get cancelled. 1, 6 are 6, 6, 6 are 36. So now we are getting as 1 by 6. Okay, so pi r square minus root 3 by 4 r square. So what is common here? Only r is common. Okay, only r is common. I can just take r outside. If I take r outside, so balance inside pi by 6. So pi by 6 minus root 3 by 4. Root 3 by 4. So I am getting this. Okay, therefore area of the segment is equal to r square into pi by 6 minus root 3 by 4. Now this is the answer. Now question number 8, 9, 10. Okay, everything is going to be, okay, some relation. Okay, everything is having, okay, relationship. 8, 9, 10. Everything is going to be in the same model. Okay, same model. Question number 8. An equilateral triangle is inscribed in a circle with the radius r. Okay, so equilateral triangle inscribed means inside the circle with the radius r. Show that the ratio of the area of the triangle. Okay, show that the ratio of the area of the triangle to the area of the circle. is equal to 3 root 3 by 4 pi. So we have to prove this. 3 root 3 by 4 pi we have to prove it. So that will be approximately 0.413. So that means we have to find out area of the triangle and we have to find out area of the circle, then take the ratio. So we have to get this answer. Okay. So now, once again, an equilateral triangle is inscribed in a circle. So now I am just taking this is an equilateral triangle. So it's equilateral triangle means all the angles it will be 60 degree. So this will be 60 degree. So each angle it will be 60 degree. So it's an equilateral triangle. We know the formula for area of an equilateral triangle. So directly we can just write. And divided by area of the circle. We know that area of the circle formula also. Only radius is given. So radius means from here to here it will be the radius. The center means this will be the radius. And this will be the radius. And this also radius. Okay, so let me find out first. Okay, what is the side? Then only we can just apply the formula. Okay, now we know that this is the radius. Okay, this is radius. Okay, I'm just drawing a perpendicular. Okay, I'm just drawing the perpendicular. So dot line. This will form 90 degree. Right, this is radius means we can say this is radius by off. From here to here it will be, okay, half of the radius. Okay, now this will form 90 degree. So we can just find out. First we'll find out this side. Okay, if the if the perpendicular is drawn from the center to the chord is bisect the chord. Okay, if the perpendicular is drawn from center to the chord is bisect the chord. Right, that means we'll apply the Pythagoras theorem for this. We'll get this side. Okay, this side, and plus one more time or two times this will be getting the side. Okay, side of the triangle. After finding the side of the triangle we can use the formula. Okay, so first you have to find out the side of the triangle. So we can just name this as, okay, if you are just taking this is A and this is B and this is C. ABC triangle. Right, I'm just taking this is center as O, A, B, C. I'm just taking as D. So in this, and a right angle triangle ODC. Okay, in right angle triangle ODC. Okay, solution. Hypotenuse square, that is R square, is equal to, okay, R by 2 square plus, okay, DC square. Okay, DC square, this square. So now R square, okay, what you can write? So R square is equal to, here also R square. So divided by 2 square is 4. So plus DC square. So we have to find out only DC. So keep DC alone to this side. So we bring R square by 4 to this side. So R square minus R square by 4 is equal to DC square. Now just take the LCM. So LCM it will be 4 cross multiply 4R square minus R square is equal to DC square. Now 3R square, okay, 3R square. So divided by 4. So divided by 4 is equal to DC square. So I have to find out only DC. Okay, therefore DC. So DC is equal to the square root of, okay, 3R square divided by 4. So 4 is a perfect square number. I can just bring it outside. Okay, R square is outside. So square root of 4 is 2. So balance we are getting as, yeah. So balance we are getting as only root 3 is balance inside. Correct? Yes. Now, so we have to find out BC. Okay, BC length we have to find out. Okay, therefore BC is equal to, we can write, so therefore BC. So BC is equal to 2 times. Okay, 2 times the DC. Okay, so 2 times. Okay, DC means so R by 2. Okay, root 3. So we can cancel this and this get cancelled. We are getting as, okay, root 3 R. Okay, root 3 R. So BC is equal to root 3 R. So actually this is area of one. Okay, one triangle. Okay, therefore area of one triangle is root 3 R. Right, so we can just write area of one triangle. So we have to find out area of, here we have 3 triangles. Okay, 3 triangles. So we can just write. So therefore, so area of Side only we found out. Okay, we have found out only side. BC is equal to root 3 R. Okay, we have found out now this is root 3 R. Now you come to the area of the triangle formula. Okay, area of the triangle formula, we know that this is an equilateral triangle. We can just apply root 3 by 4. Okay, a square. Root 3 by 4 a square. A is nothing but side square. Now only we are just applying the formula. Okay, root 3 by 4. Okay, side value we are getting as root 3r, root 3r, the whole square. Okay. So now just simplify it, we'll be getting area of the triangle. Okay, so area of the triangle, so we'll be writing as root 3 by 4, okay, into root 3 square is 3, into r square is r square. Okay. Now balance we are getting as so 3 root 3 r square by 4. Okay, we are getting as 3 root 3 into r square. Okay, r square by 4. Now this is our area of the triangle ABC. So next we have to find out area of the circle. Okay, area of the circle. So area of circle. So area of circle formula pi r square. Okay, pi r square. So radius will be keeping as it is only pi r square. So now we have to find out the ratio. Okay, ratio means so area of the circle. Okay, write the ratio. The area of the triangle to the area of the circle. Okay, area of triangle ABC. So divided by area of circle. So take the ratio. What is coming here? We are getting as 3 root 3. Okay, r square. Okay, this denominator will come as the denominator. Okay, I'm just bringing this denominator to the denominator. Okay, so this will become denominator only. So 4 into here pi r square. Okay, area of the circle is pi r square. Right, so now anything is getting cancelled. Okay, r square is getting cancelled. So balance we have 3 root 3. So divided by 4 pi. 4 pi. So we got the answer. 3 root 3 by 4 pi. Okay. Again, if you want to substitute, okay, root 3 value is 1.73 and pi value is 22 by 7 or 3.14. So you'll be getting approximately, okay, 0.413. So we no need to do this simplification part. So we got this approximately it will be equal to 0.413. We can complete. Question number 9. A square is inscribed in a circle of radius r. Show that the ratio of the area of the square to the area of the circle is equal to 2 pi. So approximately 0.637 we have to prove it. Here this a square is inscribed in a circle. Okay, the square is inscribed in a circle. The diagram. So I'm just taking a square is inscribed in a circle. Okay, if it's inscribed in a circle, we can just take it. This is R. Okay, this is R radius. Okay, so we are getting 1, 2, 3, 4. Okay, 4 triangles we are having inside. Okay, the square is dividing into 4 triangles. We know the diagonals are perpendicular bisect each other in a square. That means this will form 90 degree. Okay, here we can just easily identify the area of one triangle. If it's in right angle triangles, okay, if you know the height, okay, either we can take this as a height or this also height of base into height. Okay, so now here the solution, we have to find out area of the square. Okay, area of the square first to the area of the circle. Okay, we have to find out the ratio of area of the square to the area of circle. So first we'll find out area of the square. So area of the square is dividing into 1, 2, 3, 4. Okay, 4 triangles. Okay, area of the square is equal to 4 triangles first. We'll just write. So area of square. So it's equal to 4 times. So area of a triangle. Okay, first you will find out area of the triangle. Okay, as this is forming 90 degree, we can just use of base into height. Okay, so 4 into of, so base we can take it as this is radius. Okay, base into height also r, of base into height. So now if you're just simplifying it, 1 2s are 2, here 2 2s are 4. So balance we are getting as, okay, so 2 r square. Okay, 2 r square. Area of the square is equal to 2 r square. Area of the circle. Okay, so we have to find out area of the circle. Formula is pi r square. Okay, next one is area of the circle. So area of circle. Area of circle is equal to pi r square. Now we have to find out the ratio. So ratio is equal to area of square by area of circle. Okay, therefore, so area of square, so by area of, so area of square is 2r square. Okay, 2r square. So divided by area of circle is pi r square. Okay, r square get cancelled. We are getting as 2 by pi. Okay, we got it. 2 pi pi. So if you want to get this answer, you have to take it as pi value is 3.14. So approximately we'll be getting as 0.637. Okay, so we got the proof. Okay, so we can write. So now this is approximately is equal to 0.637. Okay, hence proof. Right. So question number 10 is a hexagon is inscribed in a circle of radius r. Okay, now hexagon is inside the circle with the radius r. Show that the ratio of the area of hexagon to the area of circle is equal to 3 root 3 by 2 by approximately 0.827. We have to prove it. Okay, so we have to show that area of hexagon to the area of circle. Okay, so we have to draw the hexagon inside the circle. Okay, let me show the diagram. Okay, hexagon is inside the circle. Okay, hexagon means we know that. Okay, so we are having 1 2 3 4 1 2 3 4 5 6. Okay, 6 equilateral triangle. Okay, so this will become an 6 equilateral triangle. Why? Because this will form an 60 degree. So total is 360. 360 divided by 6 is 60 degree. So we can say this is an equilateral triangle. Okay, so first you can find out area of the hexagon is equal to 6 times area of equilateral triangle. Okay, solution equilateral triangle. So we know that area of equilateral triangle formula, right? 6 into root 3 by 4. Okay, a square. A means we can just take the side as r. So root 3 by 4 side square is r square. Okay, now we can just simplify it. So if you are simplifying, 2 2s are 4. Okay, 3 2s are 6. So we are getting as 3 root 3 r square by 2. Okay, we are having by 2. So denominator 2. So next, area of circle. Area of circle. Formula is pi r square. Okay, pi r square. So next I have to find out the ratio. Okay, so I have to find out the ratio. So ratio it will be, so ratio means area of the hexagon divided by area of the circle. So area of hexagon is, we are getting as 3 root 3 r square. Okay, so divided by 2, this 2 will become a denominator. Okay, denominator will become a denominator. I'm just bringing the 2 denominator into here. Area of the circle is pi r square. Okay, pi r square. Here r square get cancelled. So balance we are getting as 3 root 3 2 pi. Okay, we are getting as 3 root 3 divided by 2 pi. So that's why we have to prove it. 3 root 3 divided by 2 pi. So instead of root 3, if you are taking 1.73, pi value is 3.14, you will be getting approximately 0.827. So now this is the answer. Okay, in the first question, we have learned a equilateral triangle inscribe the circle. Second one, a square inscribe the circle. Here, a hexagon inscribe the circle. The concept is going to be the same. Now they are asking, okay, can you see why the answer is exactly twice the answer to the question 8, right? So now this is the reason. An equilateral triangle in question number 8 is made 3 such smaller triangle meeting at the center. Okay, so you can just see the diagram here. Now actually this is the diagram. Okay, this is the diagram for the first one. Here in question number 8, a small triangle meeting at the center. Okay, 3 such smaller triangles meeting at the center. 1, 2, 3. Whereas in the hexagon, we have 6 triangle meeting at the center. Okay, since both are inscribed in the same circle of radius r, okay, then the hexagon simply covers exactly double. Here 3 means here 6. 3 2s are 6. So 2 times than this. Okay, double the area that is, okay, that the inscribed equilateral triangle does. That's only they are telling. Okay, can you see why the answer is exactly twice the answer in question number 8? Here 3 times 3 equilateral triangle. Here we are getting as 6 equilateral triangle. So that is exactly twice of question number 8. Okay, hope it's clear.
Thank you for watching. Kindly like, subscribe and share. Thank you.